All right, here we go. You should have already taken your notes down, so hopefully have your notes next to you. The big chart, it was very colorful. One of our previous teachers, Mrs. Kennedy, made that chart for us. So what I'm going to do is I'm going to just work out maybe 2 or 3 problems, maybe a few more if we have time, if we go quick, to help us use the notes and understand what we're doing. So the first thing I'm going to do is just write a problem down. 5x to the third plus 2x squared minus 6x to the fourth plus 8. Number one, it has to be in standard form. So negative 6x to the fourth has to come first, plus 5x to the third plus 2x squared plus 8. Okay, so this is standard form. Now, the paper you have to do today is going to ask you a bunch of questions. Questions like, what's the degree? How many turns? How many terms with an M? These are two different things, okay? It'll ask you if your coefficient is positive or negative, and it'll ask you about the end behavior, and it might even ask you to sketch a graph. So we're going to go over a few of these things real quick. I promise this is not hard. There is no math involved, no algebra, but it is memorizing and understanding where the answers come from. So first and foremost, our degree comes from the highest exponent. So my highest exponent is a 4, so my degree is 4. So I know that the highest exponent is a 4, so my degree is 4. This is called a quartic. You need to know these names. A quartic, like a quarter. 4 quarters make $1, okay? If I have a degree of 4, the terms are very easy to find because my term is 1 less than my degree. So if I have a degree of 4, then my graph can have 3 turns. If I have a degree of 5, my graph can have 4 turns. Terms with an M are how many things or items are in my equation. So I have 1, 2, 3, 4 terms. There are 4 separate items in my problem. A coefficient, remember a coefficient's what's in front. This is the coefficient of the highest exponent. So what's really wise is when you get this equation, I would highlight, circle, star this very first term, your highest exponent, because that's going to give you half of these answers. So my highest exponent, my coefficient is negative. That's all I care about. Is it positive or negative? Okay. And then my end behavior, I'm going to have a left end behavior and I'm going to have a right end behavior. What that means is whenever I have a graph, I have a left side of my graph and a right side of my graph, and I care about which way the arrows are pointing. So my end behavior comes from my degree. And I care if my degree is even or odd. If my degree is even, then my end behaviors are the same, meaning they have to have the same arrows. If my degree is odd, then they are opposite arrows. So let's look up here. We have a degree of 4. So that is an even degree. So even means they have to be the same. They're either both pointing up or both pointing down. The coefficient tells us which way they are pointing. So since my coefficient is negative, my arrow is down. And since they are even, the same, this arrow is down too. If I were to ask you to sketch a graph, doesn't have to be perfect, it's just a sketch. Here's the easy way to do it. I know both arrows have to be down, so my left side is down and my right side is down. Between these two arrows, my graph can turn 3 times. So there's 1 turn, 2 turns, 3 turns. Turn number 1, turn number 2, and turn number 3. Okay, let's go try another one. We're going to do a few real quick. So what if I give you the equation 4x cubed minus 5x squared plus 2x? So first thing I have to do is check in standard form. This one is in standard form. I'm going to box my first term because it's the important one. So first question is my degree. What's the highest degree that this equation goes is a 3. This is called a cubic, and I'm going to write that it's odd because remember up here I told you you had to know if your degree was even or odd. 3 is an odd number. How many turns does this graph have? Well, if I have a degree of 3, I can have one less turn, so I could have 2. And then terms, how many terms does it have? 1, 2, 3. Do you see how these are the same and these are the same? That's coincidence. That does not happen all the time. Don't think it does, okay? Let's talk about a coefficient. So my coefficient is the number in front. My highest exponent is a 3. The coefficient in front is a 4, which is a positive number. And then my end behavior. My end behavior has a left side and a right side. Okay, so really pay attention here. I know that my degree is odd, and odd means they have to be opposite. That means one has to be up and one has to be down. Okay, how do I know which one? Whatever my coefficient is, this coefficient goes to the right side. It's how my graph ends. So positive means my right side is positive. And if they have to be opposites, if the right side is positive, the left side is negative. So if I go sketch a quick graph, I know that my left side is negative. I know my right side is positive. I need something that only has 2 turns. So there's 1 turn and 2 turns. And if I wanted to label turn 1 and turn 2, so I know that there's 2 turns. Oops, sorry, just 1 second. Okay, so let's try to go backwards real quick. What if I give you a graph? So I'm going to sketch a little graph. And we're going to answer the same questions we answered before. Degree, turn. The only question you cannot answer from a graph is terms. We'll put it on here and then we'll make that note that we can't answer that question. Okay. What else did I have on there? Coefficient. And end behavior. A left side and a right side. So first thing first, terms. You cannot answer from a graph, not from graph. You can only answer this from an equation. Okay. Where do I start when I have a graph? There are many places you can start. I like to start here, number 1. Okay. How many turns does my graph have? Well, I have 1 turn, 2 turns. So I know I have 2 turns. If I have 2 turns, how many degrees do I have? Well, my degree is always 1 more. So my degree is 3. This is called a cubic, and I know this is an odd degree. So my end behavior, I'm just drawing the arrows. On the left side of my graph, I see a positive, and on the right side of my graph, I see a negative. And that matches odd because odd is opposites. My coefficient, if you remember from the previous problem, this coefficient has to come from the right side. So if my right arrow is negative, my coefficient is negative. Okay. Let's try one more graph. Then I want you to really try on your problems that we have that I gave you today. Okay. All right, so I need a degree, turn. Remember, terms we can't get from a graph, so I'm not going to write that on there. Coefficient, and then my end behavior. Left side and right side. Okay, so first I like to start at turns. How many turns do I have? Let's count them. 1, 2, 3 turns. So I now have 3 turns. And if I have 3 turns, I have to have 1 extra degree. So that would be a 4. That is called a quartic. And I know this is an even number. What does an even number tell me? That my left and right better be the same direction. And looky here, they are. My left arrow is pointing down, and my right arrow is pointing down. And then the last thing is my coefficient. Remember, my coefficient comes from the right side. So if my right arrow is pointing down, then my coefficient is a negative. I want you to use these 4 problems and really go try your hardest on that assignment that I gave you today. This is all it is. So if you can memorize how to find these things, then you can master topic 3.